Hello everyone, welcome to our YouTube channel. Hope you all are doing well. Today, we'll be exploring key concepts from the computer networks and network security basics and discuss some common hacking attacks. Let's get started. Network security is a critical aspect of computer networks, especially with the rapid advancements in this field. As technology evolves, the threat of intrusions and attacks has grown significantly, particularly in wireless networks, where the medium itself is inherently vulnerable. Hackers exploit these vulnerabilities to launch various types of attacks, such as eavesdropping, man-in-the-middle attacks, denial of service, and more. These attacks can compromise sensitive data, disrupt communication, or even bring entire networks to a halt. In this video, we'll dive deep into understanding these network attacks and the techniques hackers use to exploit weaknesses in computer networks. Stay tuned to learn more about how these attacks work and their impact on modern networks. Overview of network security. Network security is one of the most critical concerns in data networks today. With the rapid growth of communication networks, security issues have become a top priority for end users, administrators, and equipment suppliers alike. Despite significant collaborative efforts to develop effective security solutions, hackers continue to exploit weaknesses in the Internet infrastructure. These vulnerabilities allow them to introduce new and increasingly serious threats, posing challenges for network reliability and safety. In this video, we'll explore the various network attacks and techniques used by hackers to target and compromise systems. Elements of network security. Network security primarily focuses on two key elements. Confidentiality. This ensures that information is accessible only to those who have rightful access. It safeguards sensitive data from being accessed or intercepted by unauthorized users, maintaining privacy. Authenticity and integrity. This involves verifying both the sender of a message and the message itself at the receiving end. Authenticity confirms the identity of the sender, while integrity ensures that the message has not been altered during transmission. These foundational principles are critical in maintaining secure and trustworthy communication within a network. In a network without security mechanisms, communication between users can be easily compromised. For example, as shown in Figure 1, when user 1 sends a message like, "I am user 1 foot to user 2, an intruder can intercept it, modify the content to, "Hi, I am user 1," and forward the altered message to user 2. Without proper authentication, user 2 has no way of knowing that the message has been tampered with. However, as depicted in Figure 2, introducing a security block at both ends of the communication enhances protection. By using a secret key shared exclusively between user 1 and user 2, the message is transformed into a form that cannot be altered by an intruder. This ensures that only authorized users can access or modify the data. That said, it is essential to note that no protocol or network architecture can guarantee complete security. The Internet routing system, built on distributed networks of routers, switches, and protocols, is inherently vulnerable. These vulnerabilities can lead to issues such as misdelivery or non-delivery of user traffic, misuse of network resources by unauthorized entities, network congestion and packet delays due to malicious activities, violation of local routing policies, compromising the reliability of the system. Understanding these challenges is key to addressing and mitigating network security threats effectively. Let's discuss about various threats to network security and DNS hacking attacks. Threats to network security. Internet infrastructure attacks can be categorized into four main types. 1. DNS hacking. Exploiting vulnerabilities in DNS servers to manipulate domain name resolution. 2. Routing table poisoning. Altering routing tables to redirect traffic to malicious destinations. 3. Packet mistreatment. Tampering with or misrouting packets within the network. 4. Denial of service. Overloading end systems to disrupt normal operations. While the first three target the network infrastructure, those attacks are aimed at the end systems, causing significant disruption to services. DNS hacking attacks. The domain name system is a distributed, hierarchical global directory responsible for translating human-readable domain names, e.g., into numerical IP addresses. It is a critical component of the Internet, relied upon by all hosts to access servers and initiate connections. DNS hacking attacks exploit the centrality of this system, and their impact can be devastating. DNS is essential for email transmission, website navigation, and data transfer. A successful DNS attack can disrupt or disable these services, affecting a significant portion of the Internet. By compromising DNS servers, attackers can redirect users to malicious sites, intercept communications, or block access to legitimate services. This makes DNS security a vital concern in network security. Let's look at the different forms of DNS hacking attacks. DNS hacking attacks and their forms. A DNS hacking attack can severely impact data authenticity and integrity by manipulating the DNS system. These attacks can manifest in the following forms. 1. Masquerading attack. In this type of attack, the attacker impersonates a trusted entity within the communication process. By doing so, they can intercept and alter messages. This includes blocking messages from being transmitted, modifying the content of messages, redirecting packets to malicious or bogus servers. This form of attack is often referred to as a man-in-the-middle attack, where the attacker positions themselves between two communicating parties without either party realizing it. 2. Domain hijacking attack. This attack targets domain ownership. The attacker gains control of a domain by exploiting vulnerabilities in the DNS system. As a result, users are redirected to the attacker's website when they attempt to access the legitimate domain. This can have serious consequences, including loss of reputation and disruption of business operations. 3. Information leakage attack. In this scenario, the attacker sends a query to all hosts to determine which IP addresses are not being used. Once identified, the attacker can exploit these unused IPs to launch additional attacks, such as scanning for vulnerabilities or redirecting traffic to malicious sites. 4. Information level attack. In this type of attack, the hacker manipulates the DNS cache by providing false information. The attacker forces a server to cache incorrect data, which leads the server to provide incorrect responses to future queries. As a result, users may be redirected to malicious websites or compromised servers. These attacks can undermine the trust and reliability of the DNS infrastructure, making it essential to implement measures to secure DNS systems. Routing table attacks and their types. Routing table attack. A routing table attack refers to the unauthorized modification of routing tables, which are critical for directing traffic in a network. These attacks can significantly reduce network performance and cause problems such as lower throughput and network misrouting. There are two primary types of routing table attacks. 1. Link attack. A link attack occurs when an attacker gains access to a network link, allowing them to intercept, interrupt, or modify routing messages. This attack affects both link state protocols and distance vector protocols. In a link state routing protocol, the attacker can manipulate the routing updates sent by routers. This could lead to incorrect information being exchanged about the status of neighbors or even cause a router to remain silent, not updating its neighbors when their link states change. The result is incorrect or outdated routing information being passed through the network, leading to inefficiencies and potential disruptions. 2. Router attack. A router attack targets the routers themselves, which can affect both link state protocols and distance vector protocols. The router becomes malicious or compromised, resulting in severe disruptions. In a link state protocol, the attacker may cause the router to add non-existent links, delete valid links, or modify the cost of existing links in its routing table. In a distance vector protocol, the attacker may mislead routers by causing them to send inaccurate updates about network nodes, ultimately resulting in incorrect routing decisions. These attacks can disrupt normal network operations, cause delays, and even lead to complete communication breakdowns across the network. In today's video, we discussed several critical network security threats, including DNS hacking attacks, routing table attacks, and how hackers exploit vulnerabilities to disrupt network operations. We covered the impact of these attacks on data integrity and authenticity, as well as how they can lead to severe network disruptions. Thanks for watching. If you found this video helpful, don't forget to like, comment, share, and subscribe our channel for more tech insights.